Hi everyone, greetings of the day. In last lecture we discussed about the unit topic. I hope you thoroughly learned the topic, and next is dimension. If a question comes from this chapter in your competitive exam, most probably it will be from dimension. So be attentive and listen very carefully. Let's get started. तो चलो बच्चों अब कर दें शुरुआत नेक्स्ट टॉपिक की, that is dimension. As I had earlier also said that this is more important part in the chapter, right? So let us see what is dimension. As written here, these are the powers raised to basic physical quantities to express a given quantity. ये जो power होते हैं, these powers are called dimension. जब हम लोग किसी फिजिकल क्वांटिटी को एक्सप्रेस कर रहे हैं इन टर्म्स ऑफ अदर बेसिक फिजिकल क्वांटिटीज, लाइक इफ आई एम राइटिंग force, so force can be expressed as mass into acceleration. You all must be knowing this formula. Now what is acceleration? It can be written as change in velocity upon time. Again this change in velocity can be written as delta s by delta t, that is displacement upon time. So dimensionally it will be displacement upon square of time term, right? So now this force has been expressed into the basic physical quantities, which is mass, length and time, and its dimension can be written as, we can write F is equal to, from square bracket we represent the dimensions. It will be, for mass we write capital M, for distance term we write L, for time we write T. So it can be written as dimension of F is equal to M L T minus 2. This is dimension of force. Understood? Now let us consider another example. Let that be angular velocity, omega. As we all know, omega can be written as delta theta upon delta t. Now what is delta theta? Delta theta is length upon length term. So it has to be dimensionless, and we got only with t to the power minus 1. So dimension of omega will be t to the power minus 1. Now why we are studying about this dimensional analysis? What is its use? Why is it needed in physics? Now let us see some of its uses. The first use that we know is to check homogeneity of a given expression or equation. What is this homogeneity? In simple words we can say that it is correctness of an equation or expression. Like if it is written S is equal to, I am taking very popular equation so that you all will feel connected to it. S is equal to ut plus half a t cube. If I have written this, you all will say no ma'am, this is not correct. Okay, let us see why this is not correct. Left hand side, if you see, this is the length term. And what about right hand side? First term is velocity into time, and velocity is length upon time. So L t minus 1 multiplied with t. This t minus 1 and t, it will be cancelled, and we got again the term L only. Plus the third term, that is now half is a numeric constant. No need to write here while writing the dimension. Next is acceleration. Acceleration you all would be knowing, L t minus 2 and then t cube. This is L, but what about this? It is t minus 2 and t here. So 1 t will remain. Is this possible to add a length term to a term which is having dimension L into t? No, this is not correct. So the given expression we can say is incorrect. This is to check homogeneity of a given expression or equation. Now we have to see what are the things we have to check while checking the homogeneity of equation. The first thing is left hand side should be having the same dimension as right hand side. The first thing we have to see is that both the sides of an expression must be having the same dimension. The second thing is, if a term is appearing as power, it has to be dimensionless. Similarly, if a term is appearing in a trigonometrical term, then it has to be dimensionless. Similar is for logarithmic term, for exponential term. So we can say if a term is appearing as power, trigonometrical term, or logarithmic term, it has to be dimensionless. One more thing we have to remember, if two terms are to be added or subtracted, they must be having the same dimension. So these are the 3 points we have to keep in mind while checking homogeneity of a given expression or equation. Second use of dimensional analysis is to deduce relation among given physical quantities. Here I am taking example of acceleration due to gravity. So if we consider a simple pendulum, what are the terms that are measured? First is time period of simple pendulum, other thing is length of string, and we have to calculate G. So here these are the 3 terms to be correlated. One more thing is there in simple pendulum. You all must be knowing what is simple pendulum. Do you know this? What is simple pendulum? It is very light simple string tied to a small bob which is suspended from a fixed support. This constitutes a simple pendulum. Length of this string taken as L, mass of this bob as m. Right? Now if we have to know time period of this simple pendulum, we may consider we are actually not knowing what is the relation, though you may be knowing, but let us assume that we are not knowing the relation how t depends on L, G or m. So we can assume that t depends on L as t is proportional to L to the power a. Also we can assume that it is depending on G as G to the power b and depending on mass as mass to the power c. On combining these 3, it can be said that t is proportional to L to the power a, G to the power b and m to the power c. Now let us see what this relation could be. Now left hand side is having dimension of t. So the same must be for right hand side. This is length term L to the power a. Next is acceleration due to gravity. It is an acceleration term. So has to be written as Lt minus 2 to the power b and m to the power c. Now if we compare, it will be m to the power c, L to the power, this is a plus b and t to the power minus 2b. Now compare left hand side with right hand side. On left hand side, power of mass is 0. So we got c is equal to 0. The second thing is power of length also is 0 on left hand side. So 0 is equal to a plus b. From here we can write a is equal to minus of b. This is the second equation. Now come to third. On left hand side, time has power 1. So if we compare, 1 will be equal to minus of 2b. From here it can be written b is equal to minus 1 by 2 and then we got a also, that is 1 by 2. If we substitute all these values, we will get t is equal to c we had seen that is equal to 0. So it can be said that time period of a simple pendulum does not depend on mass of bob. Directly it will be L to the power a. What is a here? 1 by 2 and G to the power b, that is minus 1 by 2. This is in terms of dimension. So while writing the expression, it has to be sign of proportionality here, and we got t proportional to root under L by G. You can say that formula for time period can be deduced if we know vaguely on what quantities it may depend. So here, since we are knowing it may depend on length, it may depend on mass, it may depend on G, so we can deduce the formula. The third use is to get relation between two system of units. Now if we want to convert one system of unit into another, how dimensional analysis can be helpful in this? So let us take example. If we have to convert unit of force from SI to CGS, how it would be written? Now we know what is dimensional formula for force, that is MLT minus 2. So write MLT minus 2 in SI and the same in CGS. We are comparing these two system of units. SI and CGS for the physical quantity, that is force. What is unit of mass in SI system? That is 1 kilogram. If we write in terms of gram, that will be 1000 gram, 10 to the power 3 gram. Next is length. What is length? It is 1 meter in SI. So if written in CGS, that would be 10 to the power 2 centimeter. Next is second. So S minus. In the numerator, I have written SI unit of force. Now in denominator, it is the CGS unit. What is unit of mass in CGS? That is 1 gram. Mass of length is 1 centimeter. And mass of time again is second. This centimeter got cancelled, gram got cancelled, and we got the conversion factor, that is 10 to the power 5. Now we can say, so unit of force in SI upon unit of force in CGS is equal to 10 to the power 5. Here we can write the names also, as we know. So 1 Newton can be written as 10 to the power 5 times unit of force in CGS, that is dyne. So finally we got 1 Newton is equal to 10 to the power 5 dyne. Now let us take another example. We want conversion of unit of energy from SI to CGS. So again write the dimensional formula for energy, that is mL2 T minus 2. Write this in SI upon the same dimensional formula in CGS. What is unit of mass in SI? It is 1 kg. So if we write in gram, that would be 10 to the power 3 gram. Similarly, unit of length in SI is meter. So write in centimeter, it would be 10 to the power 2 centimeter. But here it is square of L. So this to be squared. Next is T to the power minus 2. This is second to the power minus 2. Now we are writing the same in CGS unit. It would be 1 gram, then S minus 2. Centimeter square got cancelled, gram got cancelled, S minus 2 got cancelled. Finally we got 10 to the power, this is 10 to the power 4 plus 3, 10 to the power 7. Finally it can be written unit of energy in SI, that is joule. So 1 joule is equal to 10 to the power 7 times unit of energy in CGS, which is known as erg. Its name is erg. So we got the conversion factor. In this way, we can write conversion factor from a known system to an unknown system, even the conversion to a new system. Now let us come to the next part. Now I have an example. If an object of mass m moves in uniform circular motion, a force F acts on it, whose direction is always towards the center of the circular path. In class 11th, you must have studied about this kind of force. What this kind of force is called? It is called central force, where the direction of force is always towards the center of path. So here this kind of force F, which depends on, this is given in question that it depends on mass, but exactly we are not knowing the dependence, so it can be written as F is proportional to m to the power a, v to the power b and r to the power c. Again, left hand side and right hand side must be having same dimension. So let us write dimension on left hand side, that would be m l t minus 2. It should be equal to dimension of the right hand side. This is mass to the power a, velocity term, so its dimension would be l t minus 1 to the power b. R is a distance term, that is radius, so l to the power c. If we write collectively, it would be m to the power a, l to the power b plus c and t to the power minus b. Now compare left hand side and right hand side and then pause. On left hand side, as we can see, power of m is 1. So we got the equation 1 is equal to a. From first equation itself, value of a is derived. Now come to the second one, that is length. On left hand side, power of length is 1. On right hand side, it is b plus c. So on equating, we got 1 is equal to b plus c. Next is third one, minus 2 is equal to minus b. From this third equation, we got b is equal to 2. Now substitute this value in second equation. So it can be written as 1 is equal to 2 plus c. and C we would get as minus of 1. So finally we got values of A, B and C. A is equal to 1, B is equal to 2 and C is equal to minus of 1. On substituting these values in the formula above, it will be F proportional to M V square and R minus 1, or it can be written as F is proportional to mv square by r. So have you got your popular formula where F represents the centripetal force, which is equal to mv square by r. Happy to see this force? Let us proceed further. Now we can say that so many uses are there for dimensional analysis, but is it possible to derive all kinds of formula, all kinds of expression to check with the help of dimensional analysis, or can we deduce all kinds of expression? Let us see. So there are some limitations also of dimensional analysis. The first one is that numeric constant cannot be checked or deduced. As I had taken one example for uses, it was the third kinematical equation, S is equal to ut plus half at square. We all know this expression very well, but in place of 1 by 2, let us take 3. So now I am writing S is equal to ut plus 3 at square. If you check it dimensionally, we would get that yes, this is correct, as we know that this numeric constant is not correct. So the expression cannot be correct. Only it can be said that yes, dimensionally it is correct. So numeric constant, it cannot be checked. Even we cannot deduce the exact value of numeric constant, as we had taken in earlier example and got time period of simple pendulum. So T was proportional to L by G, but we cannot say that if this proportionality constant is replaced with equal to sign, what would be the numeric constant involved? That is equal to 2 pi, which cannot be deduced with the help of dimensional analysis. So this is one of the limitation of dimensional analysis. Now come to the second limitation. The second limitation is that dependence of any type other than multiplication or division cannot be deduced with help of dimensional analysis. As I have just discussed that we can write dependence as, like if z depends on some quantities x and y, so we can write z is proportional to x to the power a and y to the power b. What kind of dependence is this? Only of product and division type. If it would depend on x and y as z is equal to x to the power some constant involved and plus or minus y to the power some other constant, can it be deduced? No. Similarly is the case with if dependence is of logarithmic type, if it is of trigonometric type or any other kind, right? So only product or division can be deduced with the help of it. Of course, we can check all kind of dependence. It can be checked but cannot be deduced. Now the third limitation is that if a physical quantity depends on a large number of variables, let us see that if z depends on so many things, it can be a, b, c, d, e, f, and so many powers also would be involved. So let us take the powers as p, q, r, s, t and v, right? So we wrote the dependence as z is proportional to a to the power p, b to the power q, c to the power r, d to the power s, e to the power t and f to the power v. Now what happens? If we write the equation on equating left hand side and right hand side dimensionally, we would get how many equation we are going to get? Because we have only m, l and t as basic physical quantity. So with the help of m, l and t, we can get only 3 equations. But here so many variables are involved. It is 1, 2, 3, 4, 5, 6 variables, which cannot be solved with the help of only these 3 equations. Even if it is an electrical system, one more basic physical quantity can be written, that would be current. Even if thermodynamic system is involved, one more will be there, which is temperature, but still we have only 5 basic physical quantities, and with help of these so many large number of variables cannot be derived. That physical quantity, if it depends on a large number of variables, it cannot be deduced with the help of dimensional analysis. So these were the uses and limitations of dimensional analysis. Now we are going to solve some of the problems based on this which may come in your competitive exams. Let us proceed. Here you can say question number 1, which says that power depends on so many things. X is distance, n is number of moles, r is gas constant, and theta is temperature, and dependence is given here. So dependence is given here as P is equal to alpha upon beta e to the power alpha x upon n r theta, and we have to write what will be dimensional formula of beta. Now let us see, this is the term which is appearing as power, so it has to be dimensionless. Now what is the term? It is alpha x upon n r theta. Among these quantities, x is a known thing which is distance, n is number of mole, r is gas constant, and theta is temperature. So if we write dimensional formula for all these, we can get dimensional formula of alpha as well. That should be equal to m0, l0, t0. So dimensional formula of alpha would be, dimensional formula for n, it is dimensionless. Dimensional formula of r. Now what is dimensional formula for theta? That is K, Kelvin, upon dimensional formula for x is L. Now dimensional formula of r first has to be written. So let us take help of, I am doing rough work here, you can do on your notebook as well. Now we have to write, we have to get dimensional formula for r. So let us write the famous gas equation, ideal gas equation, which is PV is equal to nRT. And PV term is a work term, energy term. So its dimension would be mL2 T minus 2 upon this T is not time here, it is a temperature term. Do remember this carefully. So it will give you dimensional formula for R. If we write it properly, that would be mL2 T minus 2 K minus 1. Substitute this value here. For R, I am writing mL2 T minus 2 K minus 1. 1 K is already here. These two got cancelled. And then L. Again 1 L got cancelled, and finally we got mL T minus 2. So this is dimensional formula for alpha. Now we got it. Compare this with the left hand side of equation, which is power. Now what is dimensional formula for power? Power is work upon time. For work we have mL2 T minus 2. This divided by time. So it has to be equal to dimensional formula for alpha, which is mL T minus 2. Just now we have derived upon dimensional formula for beta. From here we can write dimensional formula for beta would be mL T minus 2 into T upon mL2 T minus 2. These two got cancelled, m got cancelled, 1 L also got cancelled. So we got L minus 1 T. Which option is this? L minus 1 T. Option C you can check. Now let us do one another example. The question is, imagine a system of units in which the unit of mass is 100 kg. Here unit of mass is 100 kg. I have selected all different kinds of problems. So you will get a variety of things to be solved. Next is length. Reference is 1 kilometer, and for time this is 1 minute. Now we have to write what would be value of 1 joule in this system. Okay. So let us write, as we know, joule is unit of energy. So let us write energy in SI and then energy in this new unit, new system of unit. So energy in new system. This would be dimensional formula you all know. This is mL2 T minus 2. Again to be written in SI and then in new system. Now unit of mass in SI is 1 kg. Then for length it is 1 meter and square of this. For time this is second, 1 second, and power is minus 2. Write the same for the new system. What is mass here? 100 kg. For length it is 1 kilometer. So if you write in meter, that would be 10 to the power 3 meter and square of this. For time also it's given 1 minute, that is 60 second and power is -2. Now energy in SI is given 1 joule. This value we have to calculate. Let this be X is equal to kg got cancelled, meter got cancelled, second got cancelled, and finally we got the value 10 to the power -2 into 10 to the power -6. Then this is 60 to the power -2. So if it comes here, it would be 1 upon 3600. If it comes here, this will be 10 to the power -8 into 3600. And if you solve it, you will get 36 into 10 to the power -6. As you can see, fourth option is correct. Now you must be familiar with all kinds of numerical solving based on dimension and also from unit, right? So now you are comfortable with the chapter unit and dimension. In the next lecture we would see a lot number of questions that has already come in your previous examinations of NEET and JEE. So let us conclude our chapter with this. Bye.